In this video, we're going to continue to look at section 5.2 as we finish up our questions about polynomials. So here we were on problem B, where it says f of x is a negative x cubed plus x squared plus 2x, and it wants us to find this information based on that function. So first we look at the degree, and remember the degree is what? It is the highest degreed exponent. So here our degree is going to be 3. The lead coefficient is the number in front of the term with the highest degree. In this case, there is no number in front, so we understand it to be a -1. The maximum number of x-intercepts is equivalent to the degree of the function. So the maximum number of intercepts is 3. The maximum number of turning points is equivalent to the degree minus 1. So in this case, there are going to be the maximum number of turning points would be 2. And now the y-intercept. We know that to find the y-intercept, we let x equal 0. So if I substituted a 0 into x, I get 0 plus 0 plus 0. So my y value would be 0. Y equals 0, which means the x-intercept is the point, or y-intercept is the point 0, 0. And finally, the end behavior. So we have a degree 3, which means that the end behavior goes in opposite directions, either starting below at -infinity and then going up at +infinity, or it starts high and decreases over most of its domain. Now, to tell what happens here, we have to look at our lead coefficient. Because our lead coefficient is negative, our end behavior will have this result. It will go up on the left and it will go down on the right. So the way we write that is we say the limit as x approaches -infinity. So as x is approaching -infinity to the left, my y value is increasing. So my function value will be +infinity, and it'll be vice versa because it's an odd function as x approaches +infinity. So the limit as x approaches +infinity of my y value here, as we go to the right, the y value is decreasing to -infinity. So that would be how we write our end behavior. All right, I'm going to ask you guys to look at problem C. It's a bit of a trick, and answer all these questions for it. Pause the video, and then we'll go through it together. All right, for problem C, we have 2x times x plus 2 times x minus 1 squared. You can see we have an x to the first power outside here with the 2x, and then we have another x to the first power. So if we multiplied these two together, we would get x squared. And here I have the x minus 1 also squared. So when I squared this out, it would give me an x squared. Now, all of these things are being multiplied. So in total, I would wind up with an x to the 4th. So my degree is 4. The lead coefficient. All right, so on this polynomial or this binomial, when it's squared, its lead coefficient is 1. Here the lead coefficient is 1. And then we do have a 2 being multiplied by those. So it will be 2 times all of those 1s. And my lead coefficient will be 2. Now the max number of x-intercepts is equivalent to the degree. So the most possible x-intercepts it could have is 4. It could have fewer, but at the most is 4. The max number of turning points is that 4 minus 1, so 3. The y-intercept. We recall that to find a y-intercept, we substitute 0 in for x. So if we did that here, we'd have 2 times 0 times 0 plus 2 times 0 minus 1 squared. The only thing that makes sense here is to look at this term. 0 times any of the rest of this stuff is going to be 0. So when x is 0, our y value, the product here, will also be 0, making our y-intercept 0, 0, and the end behavior. So we are looking at a 4th degree function with a positive lead coefficient. If we go back up to our table, a 4th degree function is even and we have a positive lead coefficient here. So we're looking at this situation. As x, whether you're going all the way to the left or all the way to the right, as x approaches infinity or negative infinity, the y values are approaching positive infinity. So that's what we wrote down here. The limit as x approaches infinity, your y value is approaching infinity, and as x goes all the way to the left, your y value is still approaching infinity. What does that look like? The most intercepts we have is 4. So there's 1, 2, 3, 4, and both ends of my function are approaching infinity. All right, that concludes section 5.2. Thanks for watching, and we'll see you in office hours or class.